Hi everybody, Mr. G here. Now we're going to talk about number operations. We kind of highlighted them in the last video. If you go over into your workspace here, you'll notice there's a couple of drop downs with names here. So numbers, if we open that, has two files: number operations .markdown, which we'll notice we can open the markdown for and potentially utilize. And we have number operations.py, which is some sample code that we could run if we ever needed to. So operations with numbers. So to start this out, we're just going to define a few variables for us to use. So we have the numbers 15, 6, 3.4, 7.6. Remembering these exact numbers is not the important part here. But going through some operations, addition works like we'd think it would. If we add two whole numbers together, we get a whole number. If we had two decimals together, we get a decimal. An interesting interaction in Python is that when you combine an integer and a float, so a whole number and a float, the result is a float even if it's going to be 0.0. So in this case, 15 plus 3.4 is 18.4. And it dynamically does that. So you don't have to worry about saying, hey, I know one of these things is a float and one of them isn't. It understands what to do in that situation. Subtraction is also similar, but we notice something odd here. 3.4 minus 7.6 is supposed to be negative 4.2, but we get this really long answer. And this is a problem with floating point number storage. So we have a finite number of ways we can store a decimal number on a computer, and so we can't keep track of every one of them. And unfortunately, sometimes nice decimals like negative 4.2 aren't a part of the list that we can store. So we instead have the closest thing to it, which is negative 4.1999, and these nines continue. So this is a drawback, but for all intents and purposes, when it does calculations, this functions like 4.2 does. You're not going to have any problems in the long term because it's off by one, in this case, billionth or trillionth of a place. It functions like negative 4.2, so seeing this isn't too much of a concern. And again, if we combine an integer and a float, it treats it overall as a float. Now this one came out as 11.6, so some floats we can store as a nice value, others we can't. Multiplication works the same way we think it does. Even mixing integers and floats creates a float. This works all normally. True division is normal division. So if we had two numbers and you divide them, you could get a decimal answer. So in this case, we've got a few samples here, including one where an integer and a float are mixed together to get a float. So this works like typical division. Integer division is dividing only a whole number out if you can. So the question here for 15 integer divided by 6, the question is how many whole times can you fit 6 into 15? And the answer is you can only fit 6 two whole times, 12, and then you'd have 3 left over. You can only fit it 2 whole times before you run out of room to fit a whole 6. And then in this case, like, you can't fit 7.6 and 3.4, so the answer is none. And you can fit 3.4 4 full times in 15 before you start running out of space and you would have to resort to a decimal. So you'll notice that these answers are very similar to the regular division answers, but the decimal point is chopped down. So 2.5 becomes 2, 0.4 becomes 0, 4.4 becomes 4. It's essentially just chopping off the decimal place. So it rounds down effectively every time. And in general, it moves towards 0. It moves towards 0. So if we had a negative number, it would round it to 0.0 as opposed to -1. It doesn't always go down necessarily. So modulo and remainder is one that is maybe a little more unique. Not a lot of people have experience with it outside of programming, but it's effectively like when you used to do long division, and you used to get an answer and a remainder out. The remainder operator is that remainder. So when we do like this integer division up here, for example, 15 integer divided by 6 was 2, we said we were going to have 3 units left over. So you notice when you do 15% 6, percent being our modulo remainder sign here, you get 3 back, the amount you have left over after you take out all the whole 6s that you can. Similarly here, we can't take out any 7.6s, so we have a whole 3.4 left over. And here we have another classic float example where it's really 1.4, but can't quite store it that easily. And I have an additional description here to help you out. The last operation is exponentiation, which is raising to a power. And the cool thing about the symbol is it's 2 stars, 2 asterisks. And this is, I like to think of it as intuitive because exponentiation is repeated multiplication. So we repeat the multiplication symbol. You use it twice with the star. And this will raise the first number to the second number. So for example, 15 star star 6 will be 15 to the 6th power, which is obviously a very large number. In this case, about 11 million. And similarly, this is 3.4 to the 7.6 power, and so on. So these are our basic operations. And in the number operations.py, I have all the exact same code. So if you wanted to change numbers around or see otherwise how the output might change, you can play around with this. And in the next video, we're going to start talking about Booleans, trues and falses.